All right, section 3.6, solving linear systems in 3 variables. 3 variables are x, y, and z. Our objective today is going to solve systems of equations in 3 dimensions algebraically. To solve these things graphically is actually very difficult. You're graphing planes and trying to see where the planes intersect, and they're intersecting at just one point, and it's just really a difficult thing to do. Things that I want to point out to you guys is a system of 3 equations with 3 variables are often called 3x3 systems. You have 3 equations with 3 variables. That means a system of 2 equations with 2 variables is called a 2x2 system. Got it? To find a single solution to any systems of equations, you need as many equations as you have variables. So if you have 3 variables, you need 3 equations to find your solutions. If you have 2 variables, you need 2 equations to find your solution. If you have 4 variables, how many equations do you need? 4. Awesome. These are some pictures. Remember, the graph of a linear equation in 3 variables is a plane, and these are what these colored things denote. I've got 3 planes. When you graph a system of 3 linear equations in 3 dimensions, the result is 3 planes that may or may not, there's a typo, intersect. The solution to the system is the set of points where all 3 planes intersect. These systems may have one solution, infinitely many solutions, or no solutions. These are all no solutions. Our planes are parallel. I don't have any answer. This is no solution. I have 2 parallel planes and one that bisects them, so there is no one solution. And here, I don't have all 3 planes bisecting each other. Here you see I've got a point, that black point right there, that is my one solution, an XYZ point. That would look like that, XYZ, a triple pair. And then here you have infinitely many solutions. Your solution is actually a line. Identifying the exact solution from a graph of a 3x3 system can be very difficult. Can be, but for you guys it won't be. Elimination and substitution can be used to reduce a 3x3 system to a 2x2 system, and then use the methods you learned in lesson 3.2 to finish. So we are going to take a 3x3 system, which is 3 equations, 3 variables, and reduce it to a 2x2 system, which is 2 equations, 2 variables, and then we can solve it just like you learned in section 3.2. Let's try our first example. As you see here, I have 3 equations and 3 variables. I've numbered the equations because for me it's easier to keep track. We're going to pull some equations. Our goal is to eliminate a variable. My goal right now is to have 2 equations with the same 2 variables. And let's see what we can do. If I look here, I think the z is the first one that we want to eliminate. Why? I don't know. Well, let's see. If I pull equation 1 and multiply equation 2 times 3, this is equation 1 and equation 2, and then I add those together, I think I can eliminate the z term. I've always looked at stuff like this as a puzzle. I think solving systems of 3 equations can be as fun as a Sudoku puzzle or something. It's just you're trying to figure out how to get rid of things. All right, so I'm going to write down equation 1. And I'm going to multiply equation 2 by 3. 2 times 3 is 6. 3 times 3 is 9. 1 times 3 is 3, and that's plus. 16 times 3, negative 48. And we're going to add these. We're doing elimination. Okay, our z term cancels, and we're left with 11x minus 11y equals 15. 55. Negative 55. You really have to work slow and watch everything. If you make one mistake in the first step, it's over. You have to start over. So double check your work at this point. 5 plus 6 is 11, negative 2, negative 9, negative 11, and negative 48, negative 7. So we're going to hold on to this equation for a second. Since you guys are working in paper, it's going to be pretty easy for you because I'm going to be using a lot of slides to solve this. So at this point, I've already used equation 1 and 2 to get this equation. Now let's go ahead and use equation 2 and 3 and eliminate the z. So I'm going to use equation 2. I'm actually going to multiply equation 2 times 2 and equation 3. So 2 times 2 is 4x minus 6y plus 2z equals negative 32. Rewrite equation 3. And use elimination to cancel out your z term. I'm left with 7x minus 2y equals negative 25. So I have 2 equations, 2 variables. You guys know how to solve these. Okay, I'm going to push pause and get another slide up. So here's the system of 2 equations. This is my 2 by 2. 2 equations, 2 unknowns. Let's go ahead and solve it. I'm going to multiply the top equation by a negative 2, the bottom equation by a positive 11, and use elimination. So that gives me negative 22x plus 22y equals positive 110. Okay, the next one, 77x minus 22y equals negative 275. Add those together. I'm left with 55x equals negative 165. Amazingly, it's a small answer. X equals negative 3. We have one answer of our triple ordered pair. We're still looking for the y and the z. I'm going to go ahead and plug this in to one of those 2 equations, just like we learned in section 3-2. 7 times negative 3 minus 2y equals negative 25. Negative 21 minus 2y equals negative 25. Add 21 to both sides. I've run out of room. Negative 2y equals negative 4. Y equals 2. Okay, next slide. We've solved for 2 variables. It's quite easy to solve for the third. I'm going to go ahead and pick equation 2. No reason other than there's just a z, no coefficient. Minus, I'm substituting in my answers. Negative 6 minus 6 plus z, negative 12. Add 12 to both sides. Z equals negative 4. So our answer is negative 3 to negative 4. That is our solution to the 3 by 3 system of equations. I'm going to work through one more. I know it's taken a long time, but practice is the only way to understand these really, really well. This one looks to be just easier maybe. First we need to pick out what variable we want to cancel. I think I'm going to shoot for z again. So first I'll work with equation 1 and 2, and how do I eliminate z? I'm going to rewrite equation 1. If you picked a different variable to cancel, we would still come up with the same answer. There's no right or wrong way. I'm going to multiply my second equation by negative 2. Oops. And I'll get negative 4x minus 6y minus 2z equals negative 2. Add those equations together. Negative 5x minus 5y, those cancel, equals 5. So I need to remember this. Okay, so far I've used equation 1 and equation 2, and I've come up with the z term eliminated. Now let's use equation 2 and equation 3 and eliminate it. I'm going to rewrite equation 2. And I'm going to multiply equation 3 by negative 1. Positive 3x, I almost made a mistake, plus 4y minus z equals negative 4. Add those two together, 5x plus 7y, these cancel, equals negative 3. I now have two equations and two unknowns. These are the two equations that we found out by eliminating our z term. So it actually looks pretty easy to do elimination with the remaining equations. I'm going to add these together. My x terms cancel, and I'm left with 4y equals 4, y equals 1. Put it back into equation. It doesn't matter which one. I actually think I'll pick the second one. We have 5x plus 9 times 1, 5x plus 9, minus 9, minus 9, 5x, negative 10, x equals negative 2. I have my y, I have my x. Z will be pretty easy to be found. Let's pick, I don't know, the second equation. 2 times negative 2, so I'm picking that equation, plus 3 times 1 plus z equals 1. Negative 4, negative 1 plus z equals 1. Add 1 to both sides, z equals 2. My triple ordered pair is negative 2, 1, 2. And you guys know you can check your answers by plugging that triple pair into each one of those equations and making sure you get a true statement. I have one more set of problems for you, but I want you to try it on your own. I know half of you don't like doing that, but it's a great way to make sure you understand it, so when you come in tomorrow you have questions, I can answer them. Alright, I'm going to try to page through sort of slowly, but you can go back and forth and rewind to look at the answer. First I grabbed equation 1 and 2, used elimination. Then I grabbed equations 2 and 3, multiplied equation 3 by 2 and did elimination. One more step, and the answer. Good job. Let me know if you have any questions in the morning.